Okay, so this is obviously going to be a video, hopefully just a quick video about this thing called interval notation. Um, it could possibly be something you've never seen before. Although I suppose there's a decent chance, like your Algebra 2 teacher or your Algebra 1 teacher, whoever, use this notation sometimes. But just in case you've never seen it before, or maybe you just need a brush up on it, it's been a while. Uh, gonna make this quick video because in AP pre-calculus here, we're gonna be probably seeing this quite a bit. As early as section 1.2. Maybe even earlier. But I think section 1.2, which is early enough. So set notation, interval notation, they're both used to describe sets of numbers or interval of numbers. So it's not like you use interval notation for intervals and set notation for sets. It's basically the same thing, okay? It's just this one just happens to be called interval notation when you're using like this kind of style, which I'll get to momentarily, what this is all about. And then like this style, it just happens to be called set notation. Okay, so really quick, set notation. Hopefully this looks familiar enough uh, for everybody. That everybody in the past has used a lot of greater than or equal to symbols or less than symbols or that kind of stuff. Inequality symbols. So all these examples are basically just random examples of domains and ranges. And then it'll just be, if your domain is written like this, or it doesn't have to be a domain. If you have a set of numbers or an interval of numbers described in this kind of notation, what would be the equivalent way to describe it in the other notation, which again just happens to be called interval notation. But along with set notation, so hopefully right out of the gate, hopefully you understand that this just means like all the x values or all the whatever, okay? Whether it's x values or it doesn't matter. Just all the numbers that are greater than or equal to -3, and that happens to be an infinite number of numbers in this set or in this interval, okay? So interval notation actually, I don't want to get like too detailed and, like I don't want to over explain this too much. But just so you know, while I'm on the topic, while I'm on the subject, set notation officially, like full, thorough, actual set notation, actually also involves like curly braces and writing whatever variable you're using, and usually it's just like the whatever variable over here, and then we have this vertical line, and then you describe the numbers. And the way this is actually read from left to right is all x, and then this vertical line technically means such that x is greater than or equal to -3. So all x's such that x is greater than or equal to -3. And you can do, and technically you can do that for all, and technically you should, but I'm not going to really care much, just so you know, about utilizing the full proper set notation with the curly braces and everything. Like this range, for example. I mean, the point is, your range is all the numbers that are in between 4 and 7, and including 4 and 7, because it's like it's not just less than, it's less than or equal to. But technically. But technically, that's how set notation is supposed to work and stuff. But remember, I want to get to interval notation. That's the main thing for this video. So, all right, interval notation. Again, it's the same thing. Set notation can all. And by the way, sorry to go back already. But set notation can also technically just be. It doesn't have to be a bunch of continuous numbers. So if you just wanted like a set of numbers that was just 2, 4, 6, 8, and that was it, like literally just those 2, 4, 6, 8, like those 4 numbers, like not an infinite list of numbers like all of these are, like this is an infinite, that's an infinite number of numbers, This represents an infinite, set or interval. Even this, all the numbers that are between 4 and 7, that's an infinite number of numbers. Okay? All of these are infinite. Okay? But if you just wanted to have a set of numbers that was just 2, 4, 6, and 8, you could just use set notation, write down some curly braces, and inside the curly braces you would just write 2, comma, 4, comma, 6, comma, 8, and then the other curly brace. So set notation is probably the only notation you can use if it's something like that, just like a finite list of numbers, okay? Interval notation, I think, pretty much has to be like a continuous, set or interval of numbers. That's, I guess it doesn't have to be infinite, but it usually is. Anyway, so let's really get down to brass tacks here. So here's what interval notation looks like if you're talking about all the numbers that are greater than or equal to -3. We do this like bracket and then -3 and then a comma, and then this is, hopefully recognize this as an infinity symbol. Okay, so this just basically means everything from -3 to positive infinity. That's right, I said positive infinity, and everything in between. Okay, so these are not coordinates. This is like a lower bound of your interval here, and then kind of like an upper bound, if it is one. Like this is technically called like unbounded because it's infinity, but so it's like an interval. Everything in between -3 and positive infinity, which kind of goes on forever. This one in blue, in bison blue, everything that's just less than 6. So since we're talking about everything that's less than 6, this actually includes pretty much numbers that go off towards negative infinity, because what's less than 6? 5 and 4, or even like 5.9, but what I'm really talking about is, -1, -2, -3, -1,000,000, -50 trillion, like pretty much infinitely small, like down towards negative infinity. So negative infinity, if you've never heard of it until right this moment, negative infinity is a thing, as your numbers go to the left on the x-axis. Forever, goes towards negative infinity, negative, okay? Notice right away here the difference in up here in pink, there was a bracket. So interval notation uses both brackets and parentheses, okay? The difference is pretty simple. Maybe you even like can think of it before I say it, what the difference is. A bracket means we are including that -3 in the list, in the set, in the interval, So because over here it's greater than or equal to -3. So the bracket means we are including -3 in the interval or the set. But a parenthesis means we are not literally including 6 in that list, because over here like it's everything that's just less than 6. So that includes numbers like 5.9, 5.999, 5.99999, like just literally everything less than 6, just not 6, So I guess in other words, with this interval notation over here, it's not like you could do parenthesis, because infinities always get parentheses. You can't literally include infinity. It's not really a number. So infinities and negative infinities always get parentheses in interval notation. But you couldn't just do, okay, ready? You couldn't just do, parenthesis, negative infinity, comma, and then write something like 5.99, and then a bracket, because no, there's numbers bigger than 5.99, but still less than 6. Like you could just go on and get infinitely close to 6. So you can't write a number here, like you can't write 5.99. You can't even write 5.9 with like a bar over it. Like the way we do it is you just write 6, but we use a parenthesis, okay? Here again, this is now a range technically, but it doesn't have to be a domain or a range, just some set of numbers. Remember, this means everything in between 4 and 7 and including 4 and 7. So a couple of brackets, a bracket with the 4, a bracket with the 7. So this right here in interval notation means everything in between 4 and 7, including 4 and including 7. This down here, this next one, probably going to finish pretty quick here now. All downhill from here. But a quick stop, because you've maybe never seen this symbol before, like this fancy R. Okay, like just kind of a double line over here, and then just like a capital R. This actually is a symbol, like a shorthand symbol, for all real numbers. So you can definitely have, like, say, an example of a domain or a range. You could definitely have a domain of a relation or a function that was just everything, all real numbers. Okay, and how do you think we use interval notation just to say all numbers, like at least all real numbers? It would just be negative infinity, comma, positive infinity, and obviously both parentheses, always parentheses on infinities. This green range, everything greater than -2. What do you think the interval notations would be to represent this? Everything greater than -2. It would be this. You would just need a parenthesis on the -2 because we're not including -2, and comma, and then we're going up to positive infinity, and then another parenthesis. Last example, how would you represent, this in interval notation? Everything that's less than or equal to 5. What would that interval notation be? 3 seconds. So that would look like this. It would go, and I guess final just point here. You probably caught on to this already, but you always put the smaller number and then the comma and then the bigger, number or whatever. So negative infinity always goes first, so it's from negative infinity, comma, to 5, and then a bracket on the 5. So that, in a nutshell, is interval notation. And again, just to kind of, summarize or kind of circle back to something, these notations can be like either one's good, you know what I mean? Like it's not like one notation's better than the other. It's just two different ways to say the same thing. Okay, and I guess I'll just finish it there.